the parameters weren't set very clearly, so that's not so good. And there were individual queries that were nearly 100,000 characters long, which is what and they were generating a lot of them, which is why these logs were filling up so fast. So, because this is what they were doing for these, basically it was doing a query and then building a list of values off of that query, which was about 1,000 odd, 2,000, 5,000 odd integers. And then just passing it in for an in, which generated this. And again, this is really very concise in Python. Shame it generates this about as bad as it possibly could be operation in there. So, and it was doing this in a tight loop. It was doing thousands of these a minute. So, and the problem here is a feature mismatch between SQL and the programming language you're writing that calls the OR. It really, you can do bad queries really easily. If you wrote that in SQL, you'd notice that you were doing this really horrible query. In Python, it looks great. What's wrong? What could possibly be wrong with that? And if you don't look at the underlying SQL, you never see it. All you'd have to do is look at the end of the log and see, tailing the log immediately made it clear what the problem was. But remember, this client had for a while, like a week, been generating 4 gigabytes of log an hour and didn't want to look at the SQL. There was almost a physical fear of looking at that log for fear of what they might find. Which is, so it was worth them paying our hourly rate. It's like the ultimate in the plumber of, yes, I could use it, but I really don't want to go into the back. I don't even want to look at the clogged toilet. You do it, please. And this is not unique. Okay, bad idioms. So this is, I don't know, are people familiar in Postgres with this problem of foreign key deadlocks? Where two operations, because of the way, when you update a record that's a child record to a parent record in a foreign key, Postgres takes a shared lock on that parent record, and this can create deadlocks even if you're doing all the right things in terms of order of operation. Not familiar with this problem? You're lucky. It's a really pain in the neck to debug. But there is this problem in Postgres where if you take it, Postgres takes a lock on a parent record if you modify a dependent record in a foreign key relationship, and that can create a surprising deadlock situation depending on the solution in this generally is if you're modifying both the parent record and the secondary record, you modify the parent record first, not second, or second, not first. So it's easy to work around, but unfortunately, that's not the way active record works in Rails. It does it does it in the wrong order from Postgres' point of view, and it's really hard to override this behavior. So Rails on Postgres gets lots of these foreign key deadlocks, and of course the problem is Postgres sucks. So yeah, unhelpful standard behavior. So this can there is a patch going in that will reduce the likelihood of this deadlock situation, just in case I just panicked you about Postgres. But again, deadlocks are a scary thing to most application programmers because one of the rules they're told over and over again is if you do the operations in the same order every time, you won't get deadlocks. And so when a deadlock occurs, it has to be a Postgres bug. And they can be really difficult to track down, especially if you don't have any data. Finding the source of it, if you have zero database skill, finding the source of a deadlock can be really challenging. Okay, so there are 8 very common problems that I've run into all the time on ORMs. But they're using ORMs, kind of, why should we care? Well, they did it to themselves. These problems are blamed on the RDBMS, not the ORM. That's the problem, is that every single one of those was originally presented to us as, why is Postgres doing the wrong thing? And for every one where they do call in a consultant and they come in and fix it and we explain it to them and show them how there's another 3 or 4 that are out there saying, these stupid RDBMSs, this wouldn't have happened if I was using MongoDB. Which is true to an extent, but of course you have other problems. And Also, even if they are calling them to fix it, we're the kind of people who are being called in to fix these problems. So it's creating, especially if you're in-house, it's creating work for yourself that you probably didn't need. And as mentioned, this is one of the primary drivers behind the NoSQL movement, is all I'm doing is slamming this object in and getting it back out. I have one application, it's the only application that will ever talk to a database, and this is a very routine comment I hear, is I've written my application, there's never going to be any other application until the heat death of the universe that will ever need to look at this data. And then, of course, they say, well, but except for management reports. Well, we'll write management reports through the web application, it will run great. And if this is the only thing you're going to do with a database, why go through all this trouble of an RDBMS? Like PostgreSQL has tuning parameters. Berkeley DB doesn't have tuning parameters. Why do I need to include tuning parameters? Okay. So there's all the bad stuff. Now, what do we do about this? How do we fix these problems that are being thrown at us? Any questions before I move on to the terraforming of Mars here? No? Good. So the first problem, of course, is every orm has its own idiosyncrasies. Every orm is, as they say, all unhappy orms are unhappy in their own way. The good part is, but you kind of these patterns start emerging about orm-related problems. Now, just to get the bad news out of the way, there are some fixes that are not quick fixes, and will have to be sold because you actually require code changes, or architectural changes. But the good news is some you can go in and plug pretty easily. Okay, this is, I would say, orm problem number one, is pathological iteration. Generally, this involves reading something in, processing it, writing it back out, over and over and over again. Storing large result sets in application objects, also doing large in-memory sorts inside the application is an extremely common orm-related problem. Select update loops, incrementing a single field and writing it back out, for example. Generally what you want to do is, this is replacing with stored procedures to single update statements. Now, this again will require either raw SQL or a compliant orm. Replacing with a single update statement depends. Hibernate's pretty good at this. The active record, Django, Esh1's not so much. You sometimes do have to draw raw SQL to do that. But the other thing you can do is replace it with stored procedure. Now, I will say, for a lot of clients, when you use the term stored procedure, immediately hives develop because it's another piece of code that's outside of their control, frequently written in another language that they're going to have to manage. And now Postgres is in a great position for this because unlike a lot of databases, you can drop in things in Python and languages that they probably know, unlike having to do it just in an SQL-based language. But there's the solution there. Transaction problems. Small, little teeny tiny transactions that don't really encompass the entire work. Transactions that are left open between requests. This is a big problem in a lot of forms if you're using any kind of connection pooler, because the framework will forget to close the transaction or leave it open, and then you have there's a notorious problem in Django about about leaving connections in idle and transaction state, which no one can seem to find. I've tried, but I can't seem to find it. And as the previous example, a transaction doesn't completely bracket an atomic sequence, where there